Hello class, in this video we're going to look at this phenomenon called the emission spectrum, and it happens in every element, and we want to look at it and see how it relates to the Bohr's model. Okay, so here are some of the emission spectrums of different elements and the sun, and what we want to know is why is it that when electricity is run through these different elements they produce these particular colors, and only these colors, and every time it's the same exact colors, and each color has a very particular wavelength, and then that corresponds to a very specific amount of energy. We want to know why is it this way. Okay, so let's check out this simulation, and in the simulation they are using Bohr's model of the atom. Remember, Bohr's model of the atom is just a model. It's just a representation of what we think the atom looks like based off experiments. Remember, the atom's too small, we can't zoom down and actually see what the atom looks like, but Bohr's model does explain, or at least tries to explain, these emission spectrum. So let's take a look at the simulation and let's try to explain what's going on. We have this red dot here, that's the nucleus. Then this little blue dot is the electron, and we can see that the electron is orbiting, going around the nucleus, and you can see it jumps up and eventually will fall back down. What we should know is that the further away the electron is from the nucleus, the more energy or excited the electron is. So the further out, the more excited, that means it's gained energy, and the closer it gets, that means it's losing energy, and you can see it jump up again. So let's try to explain what's happening here. After it falls, we see that it's on energy level 1, and these particles flying by here are just light or some type of electromagnetic radiation that carries some amount of energy. And so there is a particular distance that these electrons can go, mapped out by these orbits or energy levels. And so if this electron absorbs the right amount, the very specific amount, a quantum of energy, and you can see some of the light just goes right by it, but then it absorbs a very specific amount of energy that gets it a very specific distance away, and then when it loses that energy it's going to let off photons. So let's see if we can see if it lets off this photon, and there's the photon let off. Each time it falls down an energy level it's letting off photons. We'll see another one. And each one of these photons is a very specific color or energy of light. And that is what creates the emission spectrum. So let's review. We know that the closer the electron is to the nucleus, the lower the energy. So to get further away from the nucleus, the electron has to absorb a certain amount of energy. So for this electron to move from this energy level to the next energy level, it has to absorb a very specific amount of energy that corresponds to this distance that the electron is moved. So let's look, for example, at this series right here. If we have an electron that is on energy level 2, goes up to energy level 6, so this is 3, 4, 5, and 6, this outer energy level here, and then it falls back down to energy level 2. If we look here, 6 to 2, it's going to let off a violet colored photon that we will see and record in the emission spectrum. And to explain why this happens, we have this Bohr model. This is why Bohr's model looks this particular way. So here I have it written out. So when an electron absorbs a quantum, that's just a specific amount of energy, it moves farther from the nucleus. That means it gets excited. That's what we say, getting excited. So we see this electron absorbing some amount of energy and going to a higher energy level, or becoming excited. So when an excited electron falls back down to a lower energy state, it emits or releases a photon of radiation, which is just a light photon, a particle of light. So here's my excited electron falling back down, and this is the energy let off as light, and the frequency of the photon corresponds to the difference between the energy levels here. Okay, so the goal of this video was to explain this emission spectrum by using Bohr's model, and hopefully I did that for you. And what we should see then also is that there are amounts of energy that separate one level from another, and there can't be any in-between energy levels. Because if there were energy levels that were in between, we would have the full spectrum of light, and that's not something that we see. We see very distinct bands of light, and those bands of light correspond to each energy level. And if there were in-between levels here, then the atom would release any type of light and all light, and that's not what we see. So please bring your questions to class, and I will talk to you more about this then. Thank you.